This video will discuss various aspects of server heatsink design, including how to determine design parameters and how to select the most suitable design solutions. For the design of a heatsink, we first need to clarify the design parameters, which include power, dissipation, dimensions, thermal resistance, mechanical attachment requirements, and the weight of the heatsink. On one hand, we can gather information from the internet or the specifications of finished heat sinks. In fact, these requirements can be clearly found in Intel or AMD official design guide. Like the table here, this guide tells us the thermal design power, maximum case temperature, case to ambient thermal resistance, the dimension of heatsink. Another crucial parameter is airflow and air pressure, which are indispensable in the design of heat sinks. These parameters affect the performance of the heatsink and the selection of system fan. When the performance of the heatsink is excellent, the dependency on system fans is correspondingly reduced. This allows for cost savings in fan selection and enables the heatsink to be compatible with a wider range of systems. Here we present 4 typical one new heat sink design solution. The first type features heat pipes embedded in the base plate, making direct contact with the heat source, offering excellent performance at the lowest cost, but with a relatively low thermal limit. The second solution is the most common, where a copper plate contacts the heat source, offering a moderate balance of performance and cost. The third type is the EVAC heat sink, with a large fin area, providing strong performance and certain structural requirements for the system. The fourth is a copper fin heat sink with a vapor chamber as the base plate, which can reduce the temperature by 8 to 10 degrees compared to a standard aluminum heat sink, but at the highest cost. Due to the increased space, there are more options for 2U server heatsink design. The first two are similar to 1U server heatsink designs, but the heat pipes, in conjunction with the upper part of fins, can evenly distribute heat across the entire heatsink. The third type sacrifices the bottom fins to transfer heat to upper fins, thanks to the expanded space and advancements in manufacturing processes. 3D vapor chambers are now also being applied to server heatsink. The fourth solution utilizes a 3DVC, significantly enhancing the temperature uniformity capability, and also compensates for the reduced surface area on the top of the 3DVC by using extrusion. Of course, this solution is more costly. We've briefly introduced the design of server heat sinks, but there's so much more that hasn't been covered. If you have any questions or topics you'd like to know more about, feel free to discuss with us. You can also visit our website or send us an email. Thank you for watching.